Today I'm going to be talking about a negative inducible molecule. First, I'm going to explain what these parts are here. So these two things are separate. This part is not a part of the operon. So this plain toothpick is going to represent regulatory genes, and it's going to be the same for both of these. One of these is just going to represent when transcription is off, and one is going to represent when transcription is on. And so on these two, you can see here that there's a blue, a green, and pink dotted region. The blue is going to represent the promoter, the green is going to represent the operator, and the pink dots are going to represent the structural genes. So these regulatory genes are going to code for repressor molecule. And these papers represent my repressor molecules. This battery right here is going to represent my RNA polymerase, and it is RNA polymerase because this is transcription, not replication, so it's not going to be DNA polymerase, it's going to be RNA polymerase. And it's also to note that there are no histones in this because this is prokaryotic, not eukaryotic. And this orange tape up here is going to represent my small molecule or my siRNA. So what is going to happen here, if this transcription is off, there's no small molecule involved, and so this repressor protein is going to be able to bind to the operon, and the RNA polymerase can go no further than the promoter, so transcription cannot occur. Now, if this were an activator, it would bind onto this so that transcription could occur, and the RNA polymerase could bind, and transcription would be on, but it doesn't do that, so it is a repressor. And down here, if transcription is on, transcription is going to lead to translation, which is then going to produce the small molecule. And the small molecule is going to come and it's going to bind to the repressor, making the repressor unable to bind to the operator. And so the RNA polymerase is free to transcribe. So I'm going to have a scenario here where walking is going to represent transcription. So say you're walking down a path and a snake gets in the path. The snake is going to be the repressor. You're not going to want to walk any further because that snake is there. But if the snake sees a mouse, which is going to be a small molecule, it's going to go after the mouse instead of you, and you are free to continue on with transcription. These are my references.